Alright, this is problem 425 and we need to find the reaction forces at A and B. Alright, so let's start by drawing them in. Okay, here we have RAY, here we have RAX, okay, and here we have RBY. We know the Y forces have to be going up, otherwise the truss system would be sinking, okay? And RAX here, all right, has to be going in this direction because all of the X forces here and here are going to the right, so RAX has to go to the left. Okay, so let's put those labels on there so you can see. Alright, the first thing I'm going to do is sum of the forces X, because I can see that I'm going to have one equation and only one unknown. We're in equilibrium, so the sum of the forces X is equal to 0, alright, which is equal to we have a 20 kip force plus a 10 kip force minus RAX. Alright, so I move RAX to the other side and get RAX is equal to 30 kips. Alright, okay, so now I need to find RAY and RBY. If I do sum of the forces Y, I'm going to have one equation and two unknowns. So I think I'll do a sum of the moments, okay? And this time, just to show you that you can do it from either side, I'm going to do R to sum the moments at B, okay? So you can get some practice with that. Okay? So let's start with sum the moments at B. They're equal to 0, okay? And so I'm just going to start from B and move across, okay? So when I come over to this member, I have an 8 kip force multiplied by 15 feet. That is going to cause a counterclockwise moment, alright? So it'll be positive. So that'll be 8 times 15. Alright, now I'm going to do this 10 kip force, alright, we're pinned at B, remember, we have a 10 kip force, alright, so that is going to tend to cause a clockwise rotation and it'll be negative. And it's also times 15 feet, but it's times this 15 feet. We have to bring it down from the top of the truss to the bottom. Okay. Next force I get to is a 12 kip force. It's going to cause a positive moment, and it's multiplied by 30 feet. Alright. The next force I get to is the 20 kip force. It's going to tend to cause a clockwise rotation if we're pinned at B. So that would be a negative 20 kips. Alright, the distance it's multiplied by is 15 feet. We don't have to move it this direction. Okay, we don't have to move it in Y, we have in X, right, we need to move it down Y, down the height 15 feet. Alright, and then the last one, okay, RAX is in the line of action, so it won't be considered. RAY is going to be important though. It's going to cause a negative moment. And it's going to be multiplied by 15, 30, 45, 60 feet. Alright, so let's plug that into our calculators. We get 0 equals. So when I do all that, I get 30 kip foot minus RAY times 60 feet. Alright, so if I rearrange this to solve for RAY, I get RAY is equal to 30 kip foot divided by 60 foot. So it's going to be equal to 0.5 kips. Typing's not my long suit today, evidently. Alright, so now we know RAX, we know RAY, we need to find RBY. So let's just do sum of the forces Y. It's equal to 0, and it is equal to 0.5 is positive, that's for RAY, minus 12 kips, minus 8 kips, plus RBY. Well, let's see, did I forget any? I have 1, 2, 3, 4. I have 4 Y forces, and so let's do a little calculating on that. And I get 19.5 kips plus RBY. Okay, so that just makes RBY equal to 19.5 kips. Alright,